years old. Space explorations have been keeping us excited always, and lately, with ISRO's successful missions to Mars and the Moon, many of us have started to take keen interest in the field of space science and astronomy. In fact, I have made up a decision that I will grow up to be a space scientist and will join ISRO. Today, I'll take you all through one of the upcoming missions planned by ISRO, and it is the very first of its kind. Yes, a mission to study the sun. Exciting, isn't it? After all, we don't know much in detail about our very own sun. This mission is called the Aditya L1 mission. Aditya in Hindi and Sanskrit means the sun, and L1 is a Lagrange point. Before we understand the mission objectives, let us see what are Lagrange points. A simple sentence to explain Lagrange points are that Lagrange points are parking places in space. Lagrange points are places between celestial bodies where their gravitational forces are at equilibrium. So, when any object is stable at a Lagrange point, it won't be disturbed by the gravitational force of any of the celestial bodies. There are 5 Lagrange points in the Earth-Sun system. They are named after Joseph Louis Lagrange, an 18th century mathematician. L1 or Lagrange point 1 lies between the Sun and the Earth. From the point L1, we will get a clear view of the Sun. That is where the Aditya L1 will be deployed. The L1 point of the Sun and the Earth gives a clear and uninterrupted view of the Sun and is home to the Solar and Heliospheric Observatory Satellite or SOHO. Here we can see that the point L1 is here in between the Sun and the Earth. This image shows that the point L1 is 1 million miles away from the Earth and approximately 92 million miles away from the Sun. Because the Sun's gravitational field is so strong, the point L1 is much closer to the Earth than that of the Sun. L2 or Lagrange point 2 is the point that is in the same distance as L1 but in opposite direction. Which means that if the point L1 is here 1 million miles away from the Earth, then the point L2 is here 1 million miles away from the Earth. From the point L2, we can get a clear view of outer or deep space. L3 or Lagrange point 3 is behind the Sun, which gives us the same clear view as the point L1, but it is very far from the Earth, and it is very difficult to go and study the Sun from there. L4 or L5 both form equilateral triangles in which the distance of L4 and L5 are the same from the Sun as the Earth. These points are so stable that all the space debris is stable at these points. Here in this image, we can see that how the point L4 and L5 form equilateral triangles in the Earth-Sun system. The mission Aditya L1 aims to keep a permanent eye on the Sun without any disturbance and to observe the solar corona. The mission duration will be 5 years. And the rocket that will be used to deploy it is PSLV-XL. The launch mass will be 1,500 kg. The payload mass will be 244 kg. We will be studying about payloads in the further slides. Payloads are various systems that will be carried by Aditya L1. The first payload aims to study the parameters of the solar corona. The second payload aims to image the solar photosphere and chromosphere. The third payload aims to study the variations of the solar wind and its properties. The fourth payload aims to understand the composition of the solar wind and its energy distribution. The fifth payload aims to monitor the X-ray flares for studying the heating mechanism of the solar corona. The sixth payload aims to observe the dynamic events in the solar corona and provide an estimate of the energy used to accelerate the particles during the eruptions. And the seventh payload aims to measure the magnitude and the nature of the interplanetary magnetic field. I hope you have learned something from my presentation, and this is the end of my tour. Thank you.